Hello everyone, today we'll talk about the solution to the problem, combination sum 2. This is a standard combination sum problem, so we want to generate all the combinations of elements that were given that sum up to a given number. And the only trick here is that we cannot have duplicate combinations. So if we sort every combination, every list that we return, then all the values should be unique at that point. And of course we can try to do it just like that, so at the end just make sure that all the values that we return are unique. But there is a simpler solution, which involves modifying the basic approach. And of course the basic approach, when it comes to calculating combination sums, is to use backtracking, because it's just inherently an exponential time problem. So we can just go through all the elements that we want to add to our potential combination, and we try to add this element, and then we recurse on the rest of elements, or we decide not to take this element and we recurse without taking that element. And of course that can lead to us taking many combinations, so some combination many number of times. For instance, if it's possible to create a combination that has 2 instances of a number 3, and we have 3 instances of the number 3 on our list, then we'll have that combination for every pair of 3s on the original list. And one way to deal with that is, instead of thinking about elements, is thinking about elements in some given order, in such a way that we think about all the elements with the same value at the same time. And then we don't just decide whether or not we take that element or not, but if we take 0 of that element, 1 of that element, 2 of that element, and so on. So first we'll take our candidates, we'll remove everything that's greater than target, because it's definitely not useful for our purposes. And we'll create a counter and take most common from that counter. So that will transform our list of candidates into a list of element and the number of times that element appears. So value and the count of that element on our original list. And now we can generate all the possibilities. So we start with our result being empty and our current combination also being empty, and we go through all the possible candidates. Of course, if the value that we've created is already the same as target, then we just append our current combination and return. If we have run out of candidates, we also return. Otherwise, we take the appropriate candidate, so the candidate at position I, we start at length -1, and we recurse with I being smaller by 1. And now we have element count of those elements. So we can take from 0 to element count, both inclusive, number of times that element. So we just iterate over range of element count plus 1. The new value is the old value plus our element taken count number of times. If we have overshot the target, we break. And otherwise we just recurse with that new value. And of course we have to remember that we need to add the element to the list, to the current combination. And at the end we look at the current combination and remove all the instances of our element value from that combination, because we have to clean up after ourselves when it comes to backtracking. That's something that we have to remember to do. We start with the last element and 0 as the current value, and of course at the end, in the rest, we have all our results. And that is it.